more likely when you have fewer to choose from. Okay, bottleneck effect. Again, maybe you've heard of this. It's kind of neat, but it's basically the reduction of the diversity of a population by reducing its size. So let's say you have a really small, you have a pretty substantial population, and something happens, and this is the bottleneck. So you have when you went large, and then you kind of shrunk it down to a very small group. This can happen if there's a natural disaster of some sort, or some sort of disease comes through, and a bunch of individuals die, and you have these kind of survivors, and their composition may be completely different from the original population. You can see here the original population is dominated by, there are 3 brown mice, and then the rest are black and white. And in the new population, you just have the brown and black mice. So the future ones are just going to be brown and black. And that was just as a function of basically who survives. And so the future population and the past population look very different because of this bottleneck effect that occurred. And lastly, you have a founder effect. So this is called the founder effect because oftentimes, as it's shown here, you can have a mainland population that then migrates to another habitat. Maybe it's an island or an isolated mountaintop or something. But basically, the new population is, of course, going to be determined by who founded it. So if there are only a few individuals that are the founders of this new population, they may, again, be completely different in there. It's kind of like the bottleneck effect, because you just have a few individuals that are sampled from the larger original population, but these don't really die. It's just that this smaller group of individuals went somewhere else. Okay, so this new population, these founders, have a different makeup here. Okay, so you have no brown mice on this one, it's just the black and white, whereas in the old population you did. Okay, so this is going to be a completely different population than that one because the founders were different. Okay, and then this is just a kind of a summary of all those, and this is in your book. Okay, and then there are 2 different types of speciation, and speciation basically means that or speciation is the creation of new species. So how do new species occur? We've talked about how kind of a population can change over time. Okay, so this is what this is all about here, is in natural selection. How does the genetic makeup of a population, okay, these are one species here, okay, these are all mice, but their genetic makeup is changing over time. Okay, for all these different reasons, and natural selection can be in here as well. These are random. Natural selection, could be that there's some sort of, I don't know, a snake or something, and it's in the snow, and so all the white guys are going to be camouflaged. Okay, that would be an example of natural selection. These are random. So you're changing the genetic makeup of this population. How does this lead to speciation? How would those processes lead to new species? Okay, and there are 2 general categories. You have allopatric speciation, which is when new species are created by geographic isolation. Okay, so you can see here that if you had these mice and somehow they became isolated from each other, there was a river between them, I don't know, there was maybe there was a island that emerged or something, the founder effect, so they kind of moved over and they were the same species, but when they went to the island they couldn't interact somehow. But once you get them isolated, there may be different environmental conditions on this side than on this side, and over time, you can see here, this species, or this side of the population that's over here, is going to change in their makeup. This one, here they're all black, here they're all white, and they may become reproductively isolated over time. Okay, so they basically are going to become so genetically different that if in the future they then come to share that area again, they may not be able to reproduce together because this is going to be millions of years potentially, and this geographic isolation is needed for them to evolve into different directions. Okay, if they remained together in the same area, they would interbreed and never split off genetically. Okay, so that is the most common type of speciation, and that's what we saw in Darwin's finches, right? Because they were on different islands and didn't really move between the islands too much. Okay, there's also sympatric speciation, and this is the speciation, so the creation of new species that are in the same geographic region. So they live together, but they still become different species. Well, how is that possible? It usually happens through a process called polyploidy, and that's when an increase, and it happens with plants a lot. You can basically, so we're diploid, which means we have 2 sets of chromosomes. Polyploidy is when you have more than that, more sets of chromosomes. You can have 3, 4, and humans have kind of made this happen in plants. Because, so this has 2 sets of chromosomes, this has 4, I think, and this has 6, I believe. And we tried to increase the number of chromosomes because it makes a bigger wheat. But the second, or the instant that you have this can happen naturally too, through mutations and the failing of gametes to separate and become haploid, which is needed when you have gametes. Okay, and basically, if this happens in nature or if humans do that, then a diploid plant cannot mate with a polyploid plant. They become instantly reproductively isolated. So they can be in the same area, but once you get different numbers of sets of chromosomes between individuals in the same species, they're automatically isolated, and then they're going to kind of go off in their own direction and become different species. Okay, so this, I believe, is the last slide. I could be wrong, but I think this is the last slide. And this is just looking at the pace of evolution. So how does a species' ability to change, how is that affected by all of these things here? Okay, so a species can adapt better and kind of deal with environmental change better if the rate of change is relatively slow. Okay, so that makes sense. So here you can see their ability of a species. So this is the x-axis for all of them. The ability of a species is greatest to adapt. It adapts the greatest when the rate of environmental change is slow. If it's really fast, species have a hard time adapting, which makes sense. Okay, the next one. The population has high genetic variation for selection to act on. Okay, so a species can adapt better, best chance of adapting, when the genetic variation is more. And that makes sense. I kind of referred to that before. If you have a population of cheetahs, for instance, that are all very similar, it's going to be hard for them, very low genetic variation, it's going to be hard for them to adapt to change. Okay, so humans are well off because we have a lot of genetic variation. And the population is relatively small. Okay, so if you have a small population size, again, you're going to have the greatest ability to adapt to change, because basically a beneficial mutation can spread more rapidly in a small population than a large population. So this is just saying that the population can kind of shift its genetic makeup more quickly if it is small. And lastly, if generation time is short, so short up here, it can have the greatest ability to change. And that makes sense. If you're having fruit flies, for instance, that they can multiply in just a matter of days, that change can happen much more quickly than humans, where our generation time is what 15, 16 years if we try to push it. So it's going to be much different for organisms and species that have a short generation time than those that have a long generation time. And I believe that is it. Okay, so we're going to start on this slide in class. All right, so I hope this helped clarify what was in the book, and I will see you in class.